All right, next we are looking at the Bayesian binomial test, and this is one of the only times that I will have you click Bayesian instead of classical. And what we're doing within this, so we're in another one of our test data sets from JASP. This is the Emily Rosa data set. Again, credit where credit is due. Looking at the number of correct and incorrect decisions from therapeutic touch practitioners in her famous experience. The participants stated the correct location of the investigator's hand in 70 of 150 trials. And so our variable that we're looking at is the outcome of the trial. So whether the trial was correct or incorrect, and the data set that's been reconstructed is from that summary information. And so we're going to look at a Bayesian binomial test for this. Again, there's some things we're ignoring about other issues that could be at play here, but we're going to figure out how to run this Bayesian binomial test. Let's take a look at what the data looks like. So again, we've got our outcome variable. It is one variable. It's either correct or incorrect. This is, again, nominal data. Again, those two categories, and that's what we're looking at within this. All right, looking at our analyses to get our Bayesian binomial under frequencies. Again, another one of those. It's a little bit varied, and we're going to click on Bayesian binomial test. All right, when we do that, it will bring up this here. And there's a couple of things that we kind of can look at. So one, we'll be moving our variable over, so again, our outcome variable. We can set our test value. So at this point, our test value is set to 0.5. This is greater in that standpoint, but let's say we wanted to say set the test value for 0.75. Our test would allow us to do that. Again, we're recalculating here. So if a problem that you're looking at recognizes that you should have a particular test value, this is how we set that Bayesian test value. And then we can look at using our alternative hypothesis that it's greater than that amount, looking at our plots and looking at our base vector to try and understand our data. So kind of pointing that out is that's how we would decide to change our test value if we needed to. Might be helpful for a homework problem, foreshadowing. And let's look at this. So we've got our proportion. Of course, we're calculating back to the 0.5. And this helps us to better understand the data that we are looking at, right? That's how you run a Bayesian binomial test.